Hello everyone, and welcome back to another episode of the Change Dude podcast, where we explore transformation at the intersection of technology, people, and big ideas that shape our future. I'm your host, Saeed Rafay, and today we are going deep into a topic that's quietly becoming the backbone of intelligent, autonomous AI systems, the Model Context Protocol, or MCP. Now, if you have been following our recent episodes, we have talked about the foundation of generative AI, and we have just scratched the surface of agentic AI, the autonomous agents that don't just respond, but act, reason, reflect, and collaborate. But here's the thing, none of that is possible without some form of structure behind the scene, and that's where MCP comes in. Today, I want to demystify what MCP really is, and why it is so important, how it compares to traditional APIs, and how it could very well become the protocol of the next generation of smart systems. So let's get started. Imagine you are trying to get an AI agent to plan your trip to Tokyo. You want it to check visa requirements, compare flights, book hotels, find experiences, even optimize your itinerary based on weather and local festivals. That's not a simple query and response task like asking ChatGPT to summarize a news article. This is a multi-step orchestration involving tools, APIs, memories, decisions, and often a degree of backtracking and refinement. This is where agentic AI comes in. But for agents to work effectively, they need a shared context that helps them understand who they are, their roles and capabilities, what they are trying to achieve, which includes goals, sub-goals, and tasks, what they know so far, which means having memory, history, and knowledge, and what environment they operate in, which means tools, APIs, and external systems. Just like the internet needed TCP/IP to make computer networking scalable, agentic AI needs MCP to bring consistency, context, and control. MCP, which is short for Model Context Protocol, is an emerging specification that structures the inputs and outputs of AI models in a way that makes long-term, context-rich interactions possible. Instead of passing single isolated prompts to a model, MCP lets developers and orchestrators pass a context bundle. This includes the user's query, yes, but also the system's goals, tools, definitions, previous steps taken, memory references, and role-based instructions. In a way, it's like going from talking to a chatbot to commanding a digital assistant who knows the big picture and has access to a full dashboard of functions. What makes MCP so powerful is that it can serve as a bridge between language models like ChatGPT-4, Claude, Mistral, etc., and external tools and APIs, long-term memory stores, and workflow orchestrators. MCP lets you bind all of this together in a structured, interpretable, modular way because it's just not about talking to AI anymore. It's about working with AI. At first glance, MCP sounds just like another API layer. But that's a surface level comparison. Let's dig deeper. APIs are typically stateless. You send a request, you get a response. That works fine for web services where the context of a call is mostly contained in the parameters you pass. But with LLMs and agents, context is everything. Think of MCP as the meta API, not the service itself, but the agreement about how context should be structured, layered, and interpreted. Where APIs might offer endpoints like /getWeather or /bookFlight, MCP would describe the user's intent to travel, the sub-goals needed, for example, researching destinations, booking accommodations, etc., the tools available to the agent, the memory of past interactions, the agent's current plan and progress. MCP doesn't replace APIs, it helps AI use APIs more intelligently. An MCP package is typically made of multiple components. First, System persona, which defines what kind of agent this is. Is it a financial advisor, a legal assistant, or a coding tutor? Second comes objective definition, which means what is the agent trying to do overall. Third comes task stack, the current breakdown of steps and subgoals. Fourth on the list is tool set declaration. What tools are available for action? Fifth, memory links. What previous interactions or knowledge should be kept in mind? Number 6, interaction history. A structured, machine-readable recap of what's already happened. By reading this rich context into the LLM, the model can perform actions that are not just coherent, but also strategic and iterative. Let's take a few examples where MCP is already making a difference. Developers' agents. Tools like DevGPT use MCP to let coding assistants understand project structure, dev environment, issue history, and tooling access. Customer support AI. An agent that knows past tickets, user data, and can escalate intelligently rather than reset every time. Personal health coach. Tracks your habits, adjusts goals based on weekly progress, integrates variable data and calendar schedules. These are not one-off conversations. They are persistent, evolving relationships between user and agent. And MCP is what makes the evolution coherent and scalable. MCP is promising, but it's also early stage. Some of the key challenges include standardization. There isn't a single governing body or universally accepted spec for MCP. Different labs and platforms are building slightly different versions. Then security. With deeper context comes more sensitive data. We need strict protocols for what is shared, encrypted, and stored. Model interpretation. Not all models handle structured context the same way. Ensuring consistent behavior is non-trivial. Performance overhead. Bigger context windows mean slower response times and higher compute costs. Optimization is the key. But perhaps the biggest open question is how much autonomy do we give these agents? With MCP, agents could theoretically spawn sub-agents, reason over timelines, adjust their goals, or even reject a user request if it contradicts their prime directive. That's a power we have never really granted software before. So what will the future of human-AI collaboration look like with MCP? Let's fast forward 3 to 5 years. You are not using individual AI apps at all. Instead, you have one AI operating system powered by agents that handle your finances, health, learning, career, travel, and more. Each one is specialized yet interconnected. Each one knows you well enough to anticipate needs, yet transparent enough to earn your trust. That future can't be built with chat prompts and siloed APIs. It needs shared context, inter-agent protocols, memory, tool access, and safety layers. It needs MCP. Think of MCP not just as a technical standard, but as a philosophy of AI design, one where the goal is long-term usefulness, personalization, and empowerment, not just novelty. As we enter the era of agentic systems, MCP is quietly becoming the glue that holds everything together. It's still evolving, and it will take the collective effort of open source developers, AI labs, policy thinkers, and end users to shape it right. But one thing is clear. As we build more complex AI systems, ones that think, reason, plan, and collaborate, the need for structured context will grow. MCP offers a powerful solution to that need. It bridges the gap between intent and execution, between users and agents, between static prompts and dynamic collaboration. So the next time you hear someone talk about AI agents taking off, remember, behind every smart agent is a smarter protocol. That's all for today's episode of the Change Dude podcast. If you found this insightful, make sure to share it with a friend or colleague who is curious about the future of AI. And as always, stay curious, stay grounded, and keep questioning the systems around you. Until next time, this is your host, Saeed Rafay, signing off.